All right, and so here's the final functional programming language that I put in the repo, and this is about Haskell. Basically, just rewrote a lot of the functions from homework 3 using Lisp. This time we're using Haskell, so we've got list length, nth element, remove first, substitute, list sum, duple, sort predicate, and insert. So the code is very, very short. Most of these are only like 2 or 3 lines. You can see how efficient Haskell is. They're really good with lists as well. I don't think any of these functions are anywhere more than 3 lines. So it's very easy to look through. Let's go ahead and look through some of the test cases that I wrote, and we'll run through these. This is very simple stuff. Let's go ahead and start up an interpreter. All right, so we're in here. We're going to go ahead and run Haskell. We'll load up homework 5. It'll give us a bunch of stuff. Don't worry about that. Tab characters isn't like it, but it still works. So let's go ahead and call the list length function. Do 1, 2, 3, or let's just put in like random numbers. End it. We got a list length of 6 in that length. Let's do nth element. We're going to be looking for 3. So that's 0, 1, 2, 3. So 5 is the nth element in that list. We can do the same thing that we did in this other one. And it'll say list is too short by 1 element. So that's fine. It's very, very simple, very similar to Lisp in the functionality. Remove 2 from this list. And there we go. It's the first time it sees 2 in this list. So if 2 is in there multiple times, let's see what would happen. See, it's still in there. It only removes the first time it sees 2. Let's go ahead and shorten this, make it easier. All right, substitute 1 for 2 in this list of 1, 2, 2, 1 receives 1, 1, 1, 1. Makes sense. We do a map substitute. Let's see, this substitutes 1 instead of 2 in all of these lists. So we've got a list of 3 lists. This 1.3 means it contains everything between 1 and 3. So this is a list of 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now we see this new list is 1, 1, 3, 1, 1, 3, 1, 1, 3, 4, 5, 6, 7, 8, 9, 10. And that's what that does. We're mapping a substitution between a list of lists. We can also do it this way. Substitute 2, 1. So instead of 1, 2, 4, we'll have 2, 2, 4. We can substitute A and B. Instead of A, B, B, A, we'll have A, 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 A. We can have a list sum between 1 to 10, which would be 55, but we could also do 1 to 11, which will give us 66 instead. So you can see how that works. Duple, same thing. We'll have duple of 10 eighths. And you can see there's 10 eighths in that list. We can sort predicate right there. Greater, you can see it goes from 10 to 1. And if we do the same thing but in reverse, it'll go from 1 to 10. And that's basically what we did in Haskell. It's pretty interesting, so feel free to look through the code.